What is this thing called gravity, this monster? Well, let me tell you, here's an article that came out this week, and it has to do with black holes. What are mathematicians into? Black hole and dark matter and dark energy. That's all they do these days. So anyone who's outside of that today is not a mathematical physicist. Okay, so here's, I went through the other side. Give me a second here. So here we have, if I can get it up here, here we have this article that came out. Astronomers discovered what's inside a black hole for the first time ever. And what's inside says, well, it's apparently a black hole is a hologram. That's what they discovered. That's what you're spending your money on, you know, for these people to come out and say, oh, it's a hologram. You know, is this physics or what are these people doing with public money? And here's the article. This is what they found. In Einstein's general relativity theory, there are no particles. There's just space-time, okay? In the standard model of particle physics, there's no gravity. There's just particles. Connecting the two different theories is a long-standing issue in physics. Okay, so this is the starting point. And so they continue to say particle theory is represented by one-dimensional strings. One-dimensional strings? What the hell is a one-dimensional anything? Sounds like a nothing. I mean, are they again talking about 1D axis, a 1D line, the mathematical line? Okay. No, they're talking about, they're not even one-dimensional. What they're talking about is a verb. They're talking about motion of something along an itinerary, and they call that itinerary a one-dimensional line because that's what they represent it with, even though they put a two-dimensional line to represent it with because we can see the line. And if we can see it, it's because it's got two dimensions at least. Okay, it says researchers were able to describe. Okay, so they're not going to explain, they're going to describe something, mathematically, obviously, what the gravity inside a black hole looks like. Okay, so they're not going to explain the mechanism, they're just going to describe mathematically. That's what they're going to be doing, which is what mathematics does. The inside of a black hole works off the theory of gravity. Okay, it is represented in 3D space. 3D space? What the hell is 3D space? I thought space was nothing. How can space be 3D? How can it have three dimensions if space is absolutely nothing? Okay, what is nothing? That which has no shape. If it has no shape, it has no dimensions. Period. We're done. See how easy it was? All we have to do is define these words and then we'll make sense. But now they say 3D space, you know, I don't have any idea what they're talking about. As space-time moves through it. So here we have space-time, which is a concept, and moves through 3D space, which is nothing. Oh, that's great. We have a concept moving through nothing. Makes a lot of sense. The surface of the black hole looks two-dimensional. Again, they introduce the observer. What the observer sees, what it looks like to the observer. We don't do that in science. In science, we kill the observer. No witnesses in science. We don't care what it looks like. We care what it is before you look at it. Okay? And surface is a concept that belongs to three-dimensional only, exclusively, never to two-dimensional. This gives it a holographic look because we do not see it as a 3D object. Again, talking about what people see and not what the object is before you see it. Okay? This is because the theory of particles does not work in 3 dimensions. Absolute nonsense, poppycock, idiocy. That's all we read today in the so-called scientific magazines or articles. So none of that makes any sense because they don't have the language right. They never define these terms, and they're talking about 3D space. They're talking about the concept of space-time moving, and very scary stuff, really. Okay, so what is gravity? Let's begin by finding out what the problem is. Okay, and so here's a rundown of it. Yeah, it fell to the other side. Give me a second here. Let me put it back up here. Here we go. Okay, this is a summary of gravity, the problems, etc. We had 400 years of gravity at least, I would say. You know, since at least the days of Galileo, maybe Newton. Even before then, they talked about gravity because they, you know, like Stebbins in Holland, he was throwing the balls from church, from a high church that was way up high. He was already checking the fact that one ball falls at the same rate as another one. They both hit the wooden board at the bottom at the same time, and he wrote about that. It was in 1586. So 1586, yeah, 1586, I think it was. And so we're talking about people who were already talking about gravity since those days. And here we are 400 years later, a little more, and nobody can tell you anything about gravity. No one from mathematical physics. So these people study mathematical physics. They call themselves physicists. Not a single one can tell you how gravity works after 400 years. What do they need, another 400 years? Is that what we should give them, 400 years of grants and money? Okay, is that what it's all about? Metaphysics, mathematical physics only describes, okay, all they have is descriptions, no explanation of the physical mechanism of the causes. So you're never going to find an explanation for gravity. And today we're going to find out why, okay, why they don't have any explanations for gravity. Okay. We have two objects, the Earth and the Moon. Okay, loonies allege it is spinning. Okay, and here you have the Earth and the Moon. Okay, so we have two objects. That's it. That's all you got to explain. See how easy it was? This is kindergarten stuff, because it's not like you got to explain, you know, how a car works, which is a lot more complicated than this. Here you have two objects, two rocks, essentially, the Moon and the Earth. And the Moon does not fly out of the solar system, and we say that it is because it is pulled by gravity towards the Earth. What we need to explain is what this gravity thingy is that prevents the Moon from flying out of the solar system. And again, we have two rocks, two celestial objects. That's all we have. That's how simple the system is that you have in front of you. Okay, so this is very easy. Should be kindergarten stuff. Should be for babies. And here we are 400 years later, since we started this, at least, this inquiry, this research, this investigation, and nobody can tell you why the Earth prevents the Moon from flying away. Okay? And then there's a couple more issues there. Why doesn't the Moon drift out of the solar system? That's one. Why is it tidally locked with the Earth? Okay? How did the Earth do that to the Moon from 380,000 kilometers away? Here you have tidal locking, as it's called. Okay? And this is from the National Ocean Service. Okay, so it's official. And when the Moon and the Sun are aligned, the waves here on Earth are bigger. And when the Moon and the Sun are not aligned, the waves are smaller. Okay, you see what's happening there? The little GIF on the right there. And so we have to answer that. How does the Earth, or the Moon in this case, how does the Moon affect the Earth from so far away, from 380,000 kilometers away? What are you going to put between the Earth and the Moon? That's the million-dollar question. And so, yeah, people want to do this with concepts, and they say, well, I'm going to put mass, and I'm going to put energy, and I'm going to put a force. None of those can explain the mechanism. We need, in order to explain a mechanism, you need a physical object. You need to tell me what object lies between the Earth and the Moon. Without that, you have nothing, absolutely nothing. You can't use concepts such as plasma. You can't use vortex. You can't use any of the concepts invented by mathematics. You need to put a physical object. You can put a dog if you want in there. You can put a tree, a rock, but you cannot put mass. You cannot put energy. You cannot put field. Okay, that's the issue. So, yeah, tidal locking, you got to explain why. Why is it that the Moon affects the Earth and the Earth the Moon from 380,000 kilometers away, one from the other? Can you explain it without putting ghosts and goblins? I mean, you know, if you're going to put ghosts in there, yeah, of course. Okay, so here we have it. Why doesn't the Sun fling both celestial objects, you know, the Earth and the Moon, out of the solar system? I mean, you know, here you have the Sun is twirling the Earth around itself, right? Apparently. And you can't see anything between the Earth and the Moon. Probably if you go there, you can't touch anything there. The question is there something there? That's the million-dollar question. And if you say there's nothing there, you're doing black magic. Period. We're done. You're doing black magic. You can't say that there is nothing there, because when you say that there's nothing there, or a concept such as field or energy or mass, then you're doing black magic. No, you need to put a physical object, something that binds the Earth to the Moon, something that binds the Earth to the Sun, etc., and the Moon also to the Sun, by the way. So they have to be bound. They have to be interconnected somehow, physically interconnected. Otherwise, you're using black magic. That's the question that we have in front of us. No mathematicians at any university on the planet can explain the cause in a rational manner. They have a couple out there, okay? And one of them is this fellow, Victor Toth, who we talked about for last week. And he says the following. He says, whether we think of gravity as geometry or as potential field doesn't really matter. The equations are the same. The numbers tell the same story either way. Yeah, maybe the numbers tell whatever. We don't care about that. We want to have the mechanism. What is the mechanism? How does gravity work? That's what people want to know. They want to understand that. It says the geometry in question is the geometry of space-time. Geometry of space-time? Space-time is a concept. What do you mean geometry of a concept? Sounds like the geometry of the 1D axis. You know, there's nothing there. You see all these people do geometry with abstract concepts. You can do it with an object such as a square or a cube, ideal or otherwise, doesn't matter, because you have a shape in front of you. But 1D, 0D, 4D doesn't work. Those are not objects. There's no object that is 1D, 0D, or 4D. And that's how simple it is. It's got to have shape. Okay, and yeah, if introduce all these mathematical objects, then you run into trouble, because then you can't make sense of the universe. So you can't use mathematical objects and introduce them as if they were physical objects of physics. The only part of that geometry that has a noticeable impact is the part governing time. The geometry of time. The stronger the gravitational field, the slower clocks tick. What's that got to do with geometry? The geometry of time, what are these people talking about? They're talking about nonsense, that's what it is. As to how it works, yeah, that's what we want to know, how it works. The principle of least action. Okay, I never heard of a mechanism like that, but let's find out. The action is a mathematical quantity. That's what it is. Okay, so the principle of least action. You say, okay, what is that? It's a quantity, it's a number. And so, again, it just shows you that these people are not even on the right page. Okay, they're not doing physics. And yeah, here you have it. He confirms this with what he says next, and I think in a different paper, he says, some believe that we are clever enough to eventually figure this out. So here he confirms that, nobody knows anything about gravity, but someday someone will figure it out, maybe. Okay? So that's what we're investing money in. We're these people investigating gravity, and they're doing numbers. They call them geometry of time. And then the question is whether that's going to give you the answer that you're looking for, which is, how does gravity work? What is the mechanism? So these people are researching something that does not answer the question that people ask. People say, how does it work? And these people say, here's the numbers. It's the geometry of time. Yeah. Okay, so here's a rundown of what we need to answer, okay? And again, we have this astronaut, he falls to Earth. Again, we're going to deal with two objects. Instead of the moon and the Earth, we're going to deal with the astronaut and the Earth. Two objects, two things, okay? This is what we got to answer. Why does that guy fall to Earth? He tends to fall to the center of the Earth, to be more exact, right? Okay, so the question is, we have to answer this. How does one object attract another? Why doesn't that astronaut fall out of the solar system? Why doesn't he go the other direction? Especially if he's falling towards the Earth and the Earth is being swung around the sun, that astronaut should be going in the opposite direction. Just do it with a little ball, revolve a ball around yourself, right? Here it is, very simple. You should have centrifugal force on the ball, okay? When you do like this, if I let go, this thing starts flying out. So here's the sun twirling the Earth around itself. The Earth orbits, the sun, pretty big speed, because we travel 30 kilometers per second. We're going around the sun like if we're being swung. And here's this astronaut trying to get to the Earth. He's going towards the Earth while the Earth is going around the sun. Why does he fly out? Why is he falling towards the Earth when he should be pushed outwards? Well, you say gravity. Well, yeah, it's gravity, but what is gravity? Again, what are you going to put between the astronaut and the Earth? Are you going to put nothing? Are you going to put a concept like energy, field, mass? Is that what you're going to, time? Is that what you're going to put between the astronaut and the Earth? Is that how you're going to explain the mechanism using the word time, geometry of time? Okay, so this is how some people answer the question, okay? And they say, well, God pushes the astronaut down. He just makes the astronaut fall to Earth. Okay, that's one explanation, I guess. Again, hopefully God grabs a hold of him instead of doing it from remote control, because we would not understand the mechanism if God does it from afar. He would be doing black magic, right? So God probably does something else. Maybe he just sends one of his angels, okay? And so the angel takes the astronaut downwards. Okay, that could happen. But at least now we have a mechanism. The only thing I don't understand, why would the angel have wings, if he can't flap them out there in outer space, okay? No air to, push against. But at least there is contact between the angel and the astronaut, okay? We understand that. Okay, so maybe that's one mechanism. It involves a little bit of magic there because we don't understand how the angel is coming down to earth. I mean, he can go in any direction, or you got to explain how the angel flies. We can understand how a bird flies, but an angel in space, a little difficult. Okay, that's one explanation that you can find out there. I guess some people would answer that way. Here's another one. People use and say, force, the force, may the horse be with you. So we have this force pushing the astronaut downwards, but force is a concept. So you can't say that the force pushed or pulled on the astronaut. You can't use the word force to explain gravity because that's a mathematical concept. We're talking about mechanisms here. What is the mechanism of gravity? What underlies gravity? How would you explain it to your 10-year-old kid? That's the question. And here you get the idea of what really happens as far as gravity is concerned, using the word force, and that's this notion that that we have this equation. Okay, force equals to the gravitational constant g, mass 1, mass 2 over distance squared. Okay, great. It just tells us the only thing you should keep in mind here is that according to mathematical physics, mass is equal to weight. And the reason there's no difference, the reason they are synonyms, perfect synonyms, is that they never were able to isolate mass from weight. Okay, because the way we determine mass is by weighing, whether you do it on the moon or here on Earth. Okay, so we have no definition for the word mass that is different than for the word weight. Okay, they can define it in one way, but then the way they figure it out is by weighing things. And the other thing you should keep in mind, weight is location specific. You have a different weight at different locations, or the astronaut in this case, above the Earth. Okay, so if you just take 1 millimeter step forward, you have a different weight. Okay, and people don't understand that. That's an important concept because that means that weight is location specific. You move your location, you have a different weight altogether. Okay, you weigh 1 gram more, 1 gram less, depending on which direction you move. Okay, and so we have to answer these questions. These are part of the notion, the mechanism of gravity. Okay, it's involved with gravity. Okay. So we can't just say calculation force. We need to explain the force, the cause of the force, the mechanism that underlies the force. Okay, here's another version. This is the one from general relativity, and it's the astronaut falls because somehow we have this warped space-time, a concept which they illustrate with a fishnet. Okay, so somehow the astronaut falls because of this fishnet. Okay, and apparently the Earth weighs down the fishnet. Okay, and so this astronaut has no choice but to slide or roll down the fishnet. Okay, that's the idea. But once they explain it that way, then they deny it at the end of the show, and they say, "Oh, by the way, you weren't supposed to take it literally." They say that, "Oh, you were paying attention to the fishnet or the canvas analogy." Yeah, I was paying attention because I was looking at the mechanism. They say, "Well, you're wasting your time. Here's the equation." I don't want any equation. I want the mechanism. I want to do physics, not math. And they don't understand that. They think that math is physics, and that's the end of that. Okay? And that's because they've equated math with physics when that's not the case. Physics is something else. Physics is, tell me the mechanism. And you have to explain the mechanism of why the Earth doesn't fly out of the solar system. And so they say, okay, it's warped space-time. Okay, great. Warped space-time. So the sun weighs down the canvas, fishnet, whatever, this fabric, and the Earth rolled around the depression like a ball around the roulette. Okay, we all understand the mechanism. No problem. So then you say, okay, so you're saying that there is a physical object that comes against the surface of the Earth because the Earth slides or rolls around this depression, this wall. And they say you're not supposed to take the analogy so literally. I'm trying to explain why the Earth doesn't fly out of the solar system. Don't tell me I'm taking the analogy too literally when you are giving me that explanation. You're saying that the reason the Earth doesn't fly out of the solar system is it rolls around, slides around a depression, the walls of a depression caused by the sun weighing down space-time. What is it that I don't understand? What are you saying? If you give me that analogy, which I understand perfectly, why then do you take it out later on and say, oh, by the way, don't pay attention to the analogy? I need to explain why the Earth doesn't fly out of the solar system. So don't tell me not to take it literally. Of course I'm going to take it literally. Physics had better be literal. And physics means that literal means that you should be able to illustrate the mechanism. And if you illustrate a canvas, I'm going to take it literally. Yes. Okay. In other words, the analogy is okay, But then you can't say, oh, but that's just an analogy. You got to look at the math. I don't care about your math. I'm going to look at the analogy, and if your analogy, it's fine. I mean, you can bring a mock-up of your whole theory to the conference. That's fine, no problem. But then don't tell me, oh, don't pay attention to the mock-up because I just used it to illustrate. Well, if you illustrate it, that is your mechanism. That is your theory of gravity. Don't tell me later on not to take it seriously. That's the issue. They contradict themselves, and that's why it's irrational. Okay, here we have another version. This is the particle version, the ether version. Okay, what you're seeing, all those dots, that's known as the ether, bunch of particles. And so they say, okay, we have all these particles. Okay, and the question is, if we have all these particles, what's the mechanism? I don't understand the mechanism of why that astronaut's falling to Earth because of all those particles in the background. I mean, are the particles pushing him down? How about the particles that push him away? And so they devised a couple of explanations for the particle hypothesis here. And let me go over these two main ones. Okay, here's one. Okay, and it goes like this. They say, that if what is called a negative momentum transfer, in other words, if you throw a ball at someone, it should push them away. But they claim that when you throw the ball at someone, the ball pulls him inwards to you. You say, how can that possibly be? And they say, well, all they do is change the sign in the equation, and suddenly the motion is not away, but towards you. That's it. That's what it amounts to in a nutshell. Nachan Baez, guy who said all this, is site on, Riverside University, UC Riverside. Okay, so this is known as negative momentum transfer. That's one way, which is surrealistic, because what they're saying is that, again, I throw the ball at you, and instead of knocking you farther out, it brings you towards me, like if you were pulled by, I don't know, a spring or whatever. Makes no sense whatsoever in physics, but they say it makes a lot of sense in mathematics. Okay, fine. And here's the other version. It's known as, you could call it, it's got several names: Casimir effect, Lesage effect. Here it is. It's got all these people who reinvented year after year, even to this day. Every time someone comes around and says, "Oh, I discovered something new." "Oh, what did you discover?" "I discovered what is known today as the Lesage effect," and that is, you have all these particles all over us, in front of us and behind us. And if you remove the ones in front of us, what you have is a shadow effect, where you have particles from the outside pushing you together. In this case, fellow with his towards the donkey. And all these people, Lucretius, really around 65, 60 BC, Fatio, he was right-hand man of Newton, then Lesage, Kramer, Radiker, Casimir. Casimir did it not with gravity, he did it with electromagnetism, but the mechanism is the same. The idea is that you remove the particles between, and the particles from the outside push in. So this is the other particle mechanism that people have come up with. There could be others. I'm just giving you the two most prominent ones. Okay, but the issue is, no one has ever been able to explain gravity with particles. And in fact, we have here's Lucretius, by the way. You should read his book, De Rerum Natura, The Nature of Things. And so he said, myriad primary particles moving in many directions. And he ends up saying, of the earth does not load down the air any more than limbs are freight. It is the weights that come from the outside of ourselves that go when placed upon us. That go when placed upon us. In other words, he was saying that you have all these particles of whatever out there. Atoms, I guess he meant, because he was an atomist from Democritus. And so he believed that, that gravity essentially was all these particles that are pushing down on you, and you essentially are serving as a mask, as a shadow for something else. So you have all these levels, all these layers. And all these people, every year you come up with all these new people who say, "Oh, I discovered something new." "Oh, what did you discover?" "Well, I discovered that gravity is a shadow effect." And that's been going on for, thousands of years now, 2,000 years at least. You can't explain it with particles. And here's the man who proved it. Okay, for those of you who are interested in showing that particles cannot explain gravity at all, so you should never use particles, otherwise you'll be passing for ridicule. Okay, here it is. His name was Kant, Immanuel Kant, and he did a full study on this. You should read his book. Okay, And so what does he say? He says, I'll just go real quick because I got a couple of these. Why only these two forces? Why only repulsion and attraction? Because they are the only ones that are thinkable. And it turns out that the quantum mechanics, they came up with four forces. They have push, pull, and maybe, and perhaps. Okay, so they have four forces. And despite that, I guess they'd never read Kant. Okay, then you have when this action of a distance occurs without the mediation of matter lying between the two portions of matter, it is called unmediated action at a distance. One of the problems that Kant had and a lot of his contemporaries, and that's what we inherited today, is that these people could not imagine. Here were two objects, the Earth and the astronaut, the Earth and the moon, doesn't really matter, two objects. And one attracts the other, especially, if they're massive like the Earth. And the question is, how does it do it? And they said, well, there's nothing between them. I don't see anything. I can't touch anything there. So there's nothing there. That was a bad conclusion. Because when they said there's nothing there, they didn't realize they were introducing black magic at that point in time. If you don't put something there and you talk about action at a distance, remote control, then what you're doing is introducing black magic. And you can't use concepts. Okay? You can't say ray, you can't say wave, you can't say field, you can't say energy, you can't say mass, you can't say time. You can't use any of those words to explain the mechanism. The mechanism requires something physical, something that's physical. And first you got to define what physical is. Hopefully it has nothing to do with see or touch. Okay, see or touch are the wrong criteria, irrational criteria really, to define the word object, thing. Okay, no, you have to define thing in a different way, and we define it as that which has shape. So whatever mediator you have there, it has shape, but it cannot be seen or touched. That's the whole thing. Okay, and here we have Kant also. He says, he continues, the book has quite a bit of passages that you should really read because it's quite involved. It's the metaphysics, his book on metaphysical mechanisms of nature, 1786. And he said the difference is merely the basic attractive force doesn't offer itself so immediately to our senses. Again, they were looking at see touch, they were looking at a witness, they were looking at observer, and they said, we can all imagine push, pressure, because it's surface against surface. We all pretty much understand that when a ball comes up against another ball, or your hands against the box. But how do you conceptualize pull when you don't see the mediator? That's where the problem is. And so he says it doesn't offer itself so immediately to our senses as impenetrability. In other words, the repelling force. The push force we all understand. It's the pull force that we have trouble with because, again, he says it's not amenable to our senses. Doesn't giving us concepts of determinate objects in space because it's not felt but only inferred. Okay, so this was the whole problem. Okay, the attractive force gives the impression of being not a basic force but a derived one, meaning that you need push to derive pull. That's what he was saying here. As though repulsion were the upshot of a hidden play of more basic moving forces. And like he said earlier, there's only two forces, push and pull. So he's saying that pull was derived or inferred from push. That you need two push forces to explain pull. Okay, so people who are interested in the subject should read him. I only took snippets, from his book. And here's the last one, And again, he says, the most common objection to unmediated action at a distance is the claim that a portion of matter can't directly act at a place if it isn't there. Okay, so if you have nothing there, how are you going to explain pull? But when the Earth directly influences the moon to come closer, it is acting unmediatedly on a thing thousands of miles away. And the space between the Earth and the moon might as well be regarded as entirely empty, because even if there is matter there, it has no effect on the attraction. Again, since he could not see, feel, or whatever, touch the mediator of gravity, he said there's nothing there. And so he says it's an unmediated force. That was his conclusion. But at the same time, he says you need a mediator for pull, for attraction. And so he was kind of on a path of contradiction, only because he tried to run an experiment, he tried to observe, he could not see what was there between the Earth and the moon, so he concluded there was nothing there. And the only way he could explain it, if there is something there, well, then all that space between the Earth and the moon had to be filled with objects. And he was thinking of see-touch objects, not of that which has shape. Okay? And so he says, the widespread misunderstanding of this matter is a result of confusing the mathematical contact of regions of space with their physical contact through repelling forces. But even such an apparent attraction must, deep down, involve true attraction. True attraction meaning genuine, meaning not made of push, meaning true pull. Okay? Because the portions of matter whose pressure or impact is at work wouldn't even be matter if they didn't have attractive forces. So the attempt to get rid of true attraction, genuine pull, and explain all phenomena of approach in terms of apparent attraction, meaning with push, right, moves in a circle. Okay, so he was smart enough to figure out that you cannot explain pull with push. But that's what all these bozos today came up with. They came up with push gravity. Okay, push gravity. And they want to explain it through, again, the two mechanisms, primarily those two mechanisms that are the Casimir effect. In other words, remove particles from between, and the ones from the outside push them together. That mechanism, which is a shadow gravity mechanism, you could say Lesage mechanism, Lucretius mechanism, all these mechanisms are the same mechanism essentially. They're saying, you remove particles here, or you have push particles from there, and something blocks it, and that creates, a differential from one object to another. That's the way they explain it. And the other one is the negative momentum transfer, which is absolutely ridiculous. They say we just change the sign on the equation, put a negative sign. Instead of motion outwards, we have motion inwards. Oh yeah, no kid, do it in the lab. You want to do observation, you want to do experiments, do it in the lab. Okay, prove to us that your equation works in the lab. Okay, not on paper. Okay, so here we have this gentleman. His name is Richard Muller, and he tells us what we need to explain about gravity. This you should pay attention to because he puts the finger right on the problem, right there. So anyone who wants to deal with the word gravity has to look at these two issues, number one and number two. She says, so for example, if you have the Earth, there's a big mass here, and you have you with your little mass here. Every atom on the Earth is pulling on every atom of you. You should repeat that 10 times to yourself. Every atom on Earth is pulling on every atom of you to understand what he's saying. For every atom on Earth to pull on every atom of you, they have to be physically connected. There's no other way. Okay? I don't care what you put in there. You can put a rod, you can put a steel beam, a string, a thread, a rope, a chain. You got to put something there. Okay? And you can't do it with concepts such as energy, field, mass, none of those. Charge, none of those. It says you're also pulling on it. The amazing thing about gravity is that it goes right through things. So you have to explain those two things. Why every atom on Earth is pulling on every atom of you and vice versa, and why gravity goes right through things. Those are the two things any person dealing with gravity has to explain. If you have not explained those two things, you know nothing about gravity. Just that simple. Okay, so those are the two issues any person who wants to explain gravity has to explain. The mechanisms of how you can achieve those two results. Okay, every atom on Earth pulling on every atom of you, you pulling on every atom of the Earth, one, and the other one, that gravity goes right through things, right through the wall. Goes through walls, through water, through air, goes through everything. Gravity goes through everything. How does it do that? Okay, and again, it's the only way, there's only one way, and that is all atoms are physically interconnected. Then you can explain that. You can explain those two questions, those two issues. You can explain why gravity goes through things, because they're all connected, and why every atom of you is pulling on every atom of the Earth, and vice versa. Only if every atom is physically connected. There's no other way. Okay? And again, you're going to have to explain the mechanism. There you have the two questions you got to answer. Okay, so here we have the moon again. Okay, and it's going around the Earth. And so the question is, you have two objects. And what did Muller say? Well, he says every atom of the moon is connected to every atom of the Earth. Okay, and gravity goes right through both objects. Okay, so it looks like every atom of one atom of the moon is connected to every atom of the Earth. And so let's illustrate what Mr. Muller says. He's a PhD, mathematical physics, but he's got the right questions. And here we have it. Okay, so there you have it. You see why every atom on Earth is connected to every atom of the moon. I didn't draw every atom, obviously. But now you can see why the moon doesn't fly out of the solar system, because every atom of one object is interconnected or connected to every atom of the other object. Okay, so the Earth swings the moon around itself, just like the sun swings the Earth around itself. and so on. So now we can understand why the moon doesn't fly out of the solar system. We don't need any space-time. We don't need any negative momentum transfer, none of that nonsense. We don't need, particles. We cannot explain it with discrete particles. We can't use the word force. Just say, oh, the force be with you. Yeah, great. I mean, we don't have a mechanism by using the word force. So here you have what we can answer Richard Muller's issues. And we answer both of them, why every atom of one object is connected to the other, to every atom of the other object, and why gravity goes right through things, everything. No one can have a shield protecting himself against gravity. Okay, so that's the bottom line. And here we have, just in case you say, well, Bill, you're a nobody. Let's go with somebody. Okay, let me give you a somebody. Here's Brian Greene, and he says the same thing that I just said. Okay, here it is. He says that the moon is connected like if it were connected by a rope to the Earth. Okay, you can see the rope there coming up. Okay, that's how they explain gravity. That's what they sense is happening, but then they try to explain it, or describe it really mathematically. And one person on Quora wrote this. He says, in space, gravity is the tether. Okay, yes, gravity is the tether. Very important word there. That's what Brian Greene is illustrating there. Just because it isn't a physical object does not mean it doesn't exist. Again, the tether is real. It is a physical object, but we can't see or touch it, and that's why they think there's no physical object there. But if they remove the physical object, they're doing gravity with black magic. There is a gravitational tether between the Earth and the moon. Yes, momentum keeps the moon from moving forward like the athletes imparting spin to the hammer, while gravity keeps it from flying off in a straight line, which it would do just like the hammer if gravity suddenly disappeared, which it won't because it is a fundamental force of the universe. There is also a gravitational tether between the Earth and the moon system and the sun, and between the solar system and the center of the galaxy. Exactly. So there you have it. That's what it's all about. There is a tether there, and that tether had better be, interconnecting every atom of those two objects. That's the story of gravity in a nutshell. Very easy, baby stuff. Once you see the connections, the physical connections, that's so stupid, that's so easy. And now these people say, 400 years now, studying this stuff, and they say, well, it's warped space-time, it's particles, it's the force be with you, and they have all these mathematical descriptions followed by irrational explanations. Warp space-time. You mean warp time? Is that what keeps the Earth from flying out? You're not supposed to take the analogy literally. That's what they answer. Okay? So why does a spoon fall to the floor? Okay, you let go of the spoon. Here you have a spoon. Okay, I'm going to let go of it. It falls to the table. Let me do it again. Repeatable experiment, just in case, for those of you who say that's part of science. We let go of the spoon, and you see it doesn't fall to the sky. It always falls downwards. And here's why. Okay, you have the spoon, and you let go of it. And of course, once we see the ropes that connect every atom of the spoon to every atom on Earth, I didn't draw them all, by the way, then you can see why the spoon falls downwards and not upwards. Are there ropes connecting the spoon to the moon? Of course. And there are ropes connecting the spoon to the air that surrounds our planet. Of course there are atoms out there. But where are most of the great majority of atoms which are close by? Well, they're in the direction of the center of the Earth. That's why. Okay? They're not in the direction of the moon. They're not in the direction of the sky. They're not in the direction of the air that surrounds our planet. No, they are in the direction of the center of the Earth. That's why the Earth is spherical, round, right? And it explains why the air and the water also curve around our planet. Okay? Any questions? Yeah, you had better connect every atom. You should connect the dots, and then nobody will hurt you. Okay? Then it's easy to understand gravity. But as long as you use mathematical concepts such as field and energy and charge and mass and and time, wave, then you'll never understand. You'll never understand gravity. And that's the situation today in mathematical physics. We've had 400 years of mathematical physics. Not one mathematical physicist, mathematician, can explain gravity to you in a rational manner. Okay, let's get on with some of the questions. And in fact, the first common question has to do with what we just discussed. Okay, a fellow says, are cosmic strings cracks in the universe PBS space-time? He says there's this video there, and I went to see it. And he says cosmic strings, which are under tension, have vibrations traveling around the speed of light, can pass right straight through each other. It sounds super familiar, this fellow says. In other words, he's referring to the rope. He's saying that the electromagnetic rope, which is our proposal, right? Looks like what these people who do strings, that's what they're describing. And the only clarification I'm going to make there is that the strings are one-dimensional, okay? And so they're not referring to the same strings we have. But the important thing is, as you're going to see in a second here, they talk about strings going through strings. It turns out people want to beat me up and say, Bill, how do you mean the rope goes through the rope? And you hear these people say the string goes through the string, and nobody questions that. So next time someone says, how do ropes go through ropes? I'm going to say, go talk to the string theorists, because they say the same thing, and somebody's got to question them. So please ask them first, how do strings go through strings if they're physical, right? And if they're mathematical, then they haven't explained anything. Okay, they're just saying that a concept went through another concept. I do that all the time, you know. Concept going through concepts, very easy to do. Okay, so I went to this site. It's Matt O'Dowd, okay, and this fellow runs this site, okay, PBS Spacetime. And so this is what he explains in the video. And he says, are cosmic strings cracks in the universe? Where do quantum fields come into all of this? Well, it turns out that the universe is a gigantic ice cube. So, you know, we had Big Bang, which was extreme heat, and now we have this ice cube. We're all solid stiff, I guess, right? No motion. To understand cosmic strings and to convince you that they probably do exist, so he's not going to explain to you. He's going to try to convince and persuade and try to recruit you. That's what he's going to try to do. So it's interesting that he uses that language. He says, convince you. He's going to convince you that he's right, that you should believe. Anyway, he says they have the subatomic thickness, meaning 1D. That's what he means by subatomic thickness, because the thickness of a string is known to be one-dimensional according to mathematical physics, and that's no thickness at all. So it doesn't have subatomic thickness. It has no thickness at all, like all lines in mathematical physics. But prodigious mass. So it's got a lot of mass, but it's got no thickness. And they lash through space at close to the speed of light. Man, sounds like he's talking about a ghost. You know, no thickness, 1D, right? Lots of mass, and travels at the speed of light. I thought Einstein said that if you have mass, you can't travel at the speed of light. Okay? And that's why they say close to the speed of light, because if they put it at the speed of light, they'd be violating special relativity. It says they could be the most bizarre, undiscovered entities that probably actually exist. Probably actually exist, right? Okay, maybe, yeah. If they exist, please show us the mechanism. How do they go through each other, for example, right? And here he talks about that. He says, keep heating plasma. This is how they're going to make these strings, closed-loop strings. Keep heating plasma until you hit temperatures of the extremely early universe, meaning very high temperatures, right? And a phase transition occurs in the quantum fields that underlie all particles. So they're essentially going to heat up the fields. And what is a field? I'm going to put that down there. It says field, a quantity represented by a number that has a value for each point in space and time. So field is a concept. It's more specifically, it's a number. Actually, it's a bunch of numbers. And what they're going to be talking about here is about freezing, heating up, you know, putting temperature to fields, having fields move. They're going to do all this magic with this concept, with these numbers. Okay. So keep in mind that whenever he mentions the word field, he's going to be talking about a bunch of numbers. That's all it is. And he says, we would think, it says, a field's inherent temperature massively changes its behavior. How can a bunch of numbers have temperature? Okay, that's the first problem. And it said we should think of the Higgs, which is the particle of mass, if you can understand that, as a fifth fundamental force because it arises from the same field structure as the other non-gravity forces. So he's going to get a Nobel because he says that we had four forces in quantum mechanics, right? What is it? The electromagnetic, we have the gravitational, we have the gluon, and we have the weak force. And now he's invented the fifth force. May the force go with you. It's the Higgs. He says this particle of mass is the fifth force. Okay, and it says it's the freezing of this field. They're going to freeze the field. Remember, it's an ice cube, the universe, that can give us our cosmic strings. Okay, a quantum field is just some numerical property that the fabric of space can have. Okay, so he's saying that a field is a number, confirming the definition that we have down there. That's all a field is. But he says this field has temperature, okay, and he's going to move it around. He's going to freeze it. He's going to do all these things to this field. And it's just a bunch of numbers. What's he going to do? Put the number 5 in his freezer? Is that how he's going to freeze it? Anyways, the field at any point can oscillate. So now the field is going to vibrate back and forth, up and down. Okay, going to oscillate around that value, and those oscillations have what? Quantized energy states. Okay, these vibrations can move through space. So now he's going to move these vibrations, these field vibrations. Okay, and then he says we see them as particles. So it's all absolute rubbish, nonsense. His entire language is ridiculous. Has no place in science whatsoever. Okay, all of it should be trashed. None of it has anything to do with science or with anything. Okay, so here's where he says that strings go through each other. That nobody questions. Okay, when they say that, everybody just says, "Oh, okay, that sounds right." Okay, here it is. It says cosmic strings move and vibrate. Okay, now remember there are one-dimensional wet fields that have temperature, and then they move and they vibrate. Okay, they're also under pretty insane tension. Okay? Tension, yeah, we can understand tension on the rope because it's a rope, 3D. Okay, no problem there. But these guys talk about one-dimensional strings, and they say they're under tension. Okay, this inevitably leads to collisions between segments of strings, either two distinct strings or two sections of the same string. When this happens, either the two segments pass through each other. Nobody questions that? What do you mean they pass through each other? How can strings pass through each other? Why doesn't anyone question that? Why does everybody try to beat me up and say, Bill, how do your ropes go through each other? And I'm saying, well, from now I'm going to say, just go ask Matt O'Dowd. He should know because he's saying the same thing. He's saying the strings go through each other. See how easy it is? If a straight string collides with itself, it can cut out a loop. If the loop intersects with itself again, it forms two smaller loops. They do all kinds of stuff with this stuff. They break them apart, they put them together, they sew them, they knit them, whatever. One-dimensional strings. Move, vibrate, have temperature, the whole works. And that's what they're studying, by the way. All your money, because a lot of these are public funds, most of it is, and this is what they're researching. Strings. One-dimensional strings.